Yes, friends, welcome once again to optics. I think this is part 4 of optics for IAS physics optional. Okay, so let's look at this particular problem from the 2019 year, that during reflection at plane surface or optical path is minimum. Okay, during reflection at plane surface, when the light is reflected from a plane surface like this, time or optical path is your minimum. We have to show this. We had to show this in the 2019 PYQ, which was asked. Okay, that during reflection at plane surface, time or optical path is minimum. We have to show this. Now, as found out in the previous lecture, if you haven't watched the previous lectures, then go to the link in the description or go to the pinned comment and start watching from part 1. Then you will surely understand everything. But if you haven't watched the previous lectures and you have never studied all this, then it will be very difficult for you to understand all these things. Okay, so the thing is that you must watch the previous lectures also in order to get a complete idea of this, or if else you have already studied, then in that case you will understand everything. Okay, if you have already studied and you are just coming for revision, then you will understand everything. Okay, so we have found out in the last class that dt by dx is equal to your like this. Okay, this is your value of dt by dx, and this is your equation number 1. Okay, which we had already assumed. So we had found out this. Now how did we find this? You have to watch the previous lecture in order to see how we found this. Okay, so we will use the same thing to show that the during reflection at plane surface, time or optical path is minimum. We will show with the help of this only. So dt by dx, the value is we have written as it is. Okay, which we had found out in the previous class. The thing is that whenever you find out the minima, okay, what is the maxima condition? See, at maxima, minima or stationary point, at maxima, minima or stationary point, the single differential is equal to 0. But if we want to find out that when the situation of maxima will be there and when the situation of minima will be there, then what do? You simply take the double differentiation. Okay, if the double differentiation, that is d2t by dx2, that is double differentiation, if that comes out to be your greater than 0 in case, then such a situation is that of minima. That is the situation of minima. Okay, but if suppose your dt2 by dx2 comes out to be always smaller than 0, okay, suppose this comes out to be smaller than 0, then what is this? What is the condition? This is a condition of maxima. Okay, this is a condition of maxima. So you have to know this thing very well. Okay, now dt by dx is equal to 1 over c x by square root of a square plus x square minus d minus x divided by square root of b square plus d minus x square. Now you will multiply the c over here. Okay, c will be transferred from RHS to LHS. Then c dt by dx is equal to, now speed into time is equal to distance. So it will be equal to the elementary distance ds. Okay, differential distance ds. When the speed of light will be multiplied by differential time dt, then it will be equal to differential distance dx. Okay, ds, not dx, ds. Okay, differential distance ds. So c dt by dx is equal to ds by dx. So this is the thing which you got. Simply we have moved the c to the left hand side, nothing else. Okay, we have done nothing more than that. So this is the expression which you get from here. Now d2s by dx2, if we want to find out, then how will we find out? Just simply take the differentiation of this one more time. Okay, this is single differentiation, just take the differentiation one more time. Okay, then we get d2s by dx2. If suppose d2s by dx2 if it comes out to be greater than 0, then S will be minimum. Your S will be then minimum. Yes, right? By the maximum minima condition. Okay. And same thing will apply for time also. For time also same thing will apply. When S will be minimum, the distance traveled by light will be minimum, then time taken by light to travel that distance will also be minimum. Right? This is a common sense thing. More is the distance, more will be the time required to travel that distance. If S is minimum, then time required to travel the distance will also be minimum. And when will S be minimum? d2s by dx2, when it is greater than 0, then S will be minimum. Okay. So this is the thing. So we have found out one more time differentiation. Now these differentiation steps, I don't think there is any need to even discuss the differentiation steps. Okay. How will you do it? You will apply the u by v formula. What is the u by v formula? If you want to find out the differentiation of u by v, suppose you want to find out the differentiation of u by v, then what do you do? Differentiation of u by v. So you simply take v du minus u dv, okay, divided by v square, like this. So you will apply this formula on this also and on this also. And as soon as you apply that formula on these, you get an expression of this kind, which is written over here. Okay. Now do not get confused over here. This is minus sign and this is denominator. Denominator contains this. Okay. Denominator contains this over here also. Okay. So this is in continuation. Okay. These two things are in continuation. Which two things? This thing divided by and this whole thing in division, and these things are in continuation. Okay. So these things are in continuation. So d2s by dx2, what will it be equal to? d2s by dx2 will be equal to like this, okay, which you found out over here. Okay, d2s by dx2 has come out to be equal to this much. Okay, you can find out easily. Now when you simplify it further, you get something of this kind. Okay, when you simplify it further, you get something of this kind. Okay. Now as soon as you look at this expression, what do you find? That a is your positive, b is your positive, a is your positive, x is your not positive, not a and a, b, x are not positive, but a square is your positive, b square is your positive, a square plus x square is your positive, b square plus d minus x square is your positive. Everything is square, right? Everything is square. Okay. So as everything is square, so everything is positive over here. There is no and complex number cannot come over here. Complex number have their square equal to negative, but complex numbers cannot come over here because all these things are real. We are talking about real life situation, not complex situation. Okay, we are talking about real life situation which exists in real life, and complex number do not exist in real life. So all these squares will be positive only. Okay, all these squares will be positive only because they are distances, and distances can never be complex numbers. Okay, so all these things are positive. So your double differentiation with respect to x is greater than 0. Double differentiation with respect to x is what? It is your greater than 0. So as double differentiation with respect to x is greater than 0, so s will be your minimum. Okay, that is the distance traveled by the light will be minimum. So s will be your minimum in that case. Okay, so s will be minimum. Now we will learn the Fermat's principle and laws of refraction. Okay, but about that we will learn in the next class. Hopefully you have noted this down in the notebook. There is nothing very big in it. Okay, see what do you have to do is this is u by v. Okay, so first of all you will take the differentiation of you will take this as it is over here. You will take its differentiation, then minus. Okay, then minus sign will come. Minus sign will come and you will take this differentiation and this as it is. Okay, so these are the things we have to do. U by v formula, it is very easy. Okay, it is very easy, not a complicated differentiation, it is easy only. Okay, so d2s by dx2 as it is greater than 0, so s will be minimum. Okay, so for the condition, if suppose it would have been smaller than 0 always, suppose it is always greater than 0 over here, but suppose if such a situation would have arisen, that it is always smaller than 0 condition would have arisen, then what would have happened? Then clearly S would have been maximum. Okay, then maxima condition would have arisen. Okay, so this is the thing. So d2s by dx2 is greater than your 0. Okay, so S is your minimum. Okay, so Fermat's principle and law of refraction we will learn in the next class. Thank you very much.